So for number 42, we're trying to determine whether the series is convergent or divergent. And at first we're going to use the divergence test. And the divergence test that says that if you take the limit of the terms being summed as n goes to infinity and that limit is not equal to 0, then your sum diverges. And this is because if the limit is not equal to 0, then it means that since this is an infinite sum, that you are constantly adding these non-zero terms. So necessarily your sum is going to keep changing with every term that you add, and it's never going to converge anywhere. So let's take the limit of this stuff here and see where it takes us. So if we take the limit as n goes to infinity of e to the power of n over n squared, well, if we take the limit here, that's just going to be e to the infinity is infinity over infinity squared is infinity, so this is indeterminate form. So we have to use L'Hopital. So we're going to use L'Hopital. And to use L'Hopital, we have to take the derivative of both and then take the limit once more. So we're going to take the limit as n approaches infinity of. The derivative of e to the n is just e to the n, whereas the derivative of n squared is 2 times n. So if we take this limit here, if we plug in infinity, we're going to get e to the infinity is infinity over 2 times infinity is infinity. So still undefined. So we're going to apply L'Hopital once more, and we're going to take the limit as n approaches infinity, and we're going to take the derivative of this guy here. So the derivative of e to the n is just e to the n, and the derivative of 2 times n is just 2. So if we take this limit here as n goes to infinity, we're going to have e to the infinity is infinity divided by 2, which is just infinity still. So we can see that through L'Hopital, we take the derivative twice, we're able to find this limit, and this limit is infinity. So because the limit is not equal to 0, it means that it diverges because of the divergence test. So when n gets really large, the terms that you're adding, they tend to infinity, so your sum is going to get infinitely large. And that is it for problem 42.